Section 4.2 introduces E as a base. E as a base gets used in many mathematical equations. When you get to calculus, it turns out that base E works very nicely with derivatives and integrals, so base E is the easiest base to put most of our formulas in. In this case, E, just a number, a little bit more than 2.7, to the x minus 3 is always going to be positive, and then I'm adding 4, so this is definitely going to be a positive value. So when I draw my axes, I draw my x-axis at the extreme bottom. Now I'm going up 1, 2, 3, 4, and y equals 4 will be my horizontal asymptote. As before, the special point occurs when when the exponent is 0. That happens when x is 3. So I go out 3. If x is 3, then that's 0. E to the 0 is 1. 1 plus 4 is 5. So I'm going through the point 3, 5. Now I do expect this to be exponential growth because x is going to be in a positive position here. There's not a negative in front of it. Plugging in another point is not as easy as it was with base 2. But let's see what happens if we let x be 4. If x is 4, then 4 minus 3 is 1. E to the first is just E. Remember that E is a little bit more than 2.7, so this would be 2.7-ish plus 4. That would be about 6.7. So here's 5, 6, 7. So it should go through the point 4, and then a number somewhere between 6 and 7, closer to 7. This will actually be the point 4, 4 plus E. I start low, next to my asymptote. I go through these points, and I swoop upwards. The graph, base E, is going to be a little bit steeper than the graph, base 2, but as long as you draw it curving in the appropriate direction, that is good enough for what we are doing. We do not need extra precision. Instead, we need to label key points, key attributes.